Hello folks, this is 2017 October-November paper 1-3 and the question number is 36. It is concerned with the chapter current electricity. As you can see from the diagram, it says two cells each of electromotive force E, so E and E, but different internal resistances R1 and R2 are connected in series to a resistor R. So these two cells are in series connected to a resistor R. The reading on the voltmeter is 0 volt. So you can see here it is 0 volt. So from here to here it is 0 volt. Then what is the resistance of R? So we have to find the value of R in terms of R1, R2. So what we have here is if this reading is 0, it means that the terminal PD across this first source is 0. V equal to 0 means the terminal PD across this thing is equal to 0. So that means we have the relation Vt is equal to E minus IR. So if I have I as the current in the circuit, so for this case I'll have Vt equal to 0 is equal to E minus I and then R1. So here the inner resistance is R1, so that's why it's equal to IR1. So this gives me E is equal to IR1. So let us name it as equation number 1. So for this thing, the use of the relation for terminal PD gives us E equal to IR1. Now, for this whole setup, what we have is the total EMF is E plus E. That should be equal to I into total resistance. The total resistance is equal to R1 plus R2 plus this large R. So E plus E equal to like this. So this is 2E, this is 2E. And if I open up the bracket here, it is IR1 plus I common R1 plus R. So I have just opened up one and not others. So this IR1 is equal to, let us say this is, so E is equal to IR1. So it is 2 IR1 minus, this goes here, IR1 is equal to IR plus R. So when you do it minus, it gives us IR1 is equal to IR plus R. This gives us I goes. R1 is equal to R. Sorry, this is R2, and this is R2 plus R. So this gives us R1 minus R2 is equal to large R. So that means the question asks what's the value of R. So R is equal to R1 plus minus R2. R1 minus R2. So the answer B is the correct choice.